Oh, you didn't want Nicole to sit through the fire drill?
No, I felt like that would be painful. All right, here we go.
That's kind of purple.
Okay. So let's just work through this together. Starting on page 1. Let's explore first. Looking at that function, graphing it on your calculator. So what we're going to do, when we say do these kinds of problems on your calculator, Abril, can you kill the lights for me? What I'm trying to get is, I'm trying to find patterns. It's all I'm looking for. So we start with the base equation, 2 to the x, and we graph it. Ooh, don't graph like that though. And we graph it. And we come up with this. Now, even if you don't have a calculator, even if you don't have something that can do this, all you need to do is create a table of values. All you need to do is create a table of values, x and y. Remember, our function is, we're looking at 2 to the x. So if I want to go -3, -2, -1, 0, 1, 2, 3, we plug that into our function. So 2 to the -3, 1/8, 1/4, 1/2, 1, 2, 4, 8. You plot these points, you come up with this. Okay? Who does not understand how to plot points? I'm totally being serious at this point. Alright. All we need to do is create some points to plot a function. I can give you anything you've never seen before, and you can do this now. You can graph any function you get shown. Period. Okay? You just find some values for x, you plug them into the equation, and you plot your points. That's it. That's the only trick. Haley?
I don't understand what to do when there's like a negative number like after it, or when there's like a number like, I understand how to do it with 2 and then just to the x power, but then I don't understand.
Like, what do you mean? So like the -2 or -3?
No, like I understand like that, but you just put the -3 at the end, the x power, right?
Yep.
And then, but like if you have like a negative number after like the x, like up on the x power in the equation, if you have like a negative.
And that's where we're going to go next. Okay? So the same thing happens. So this whole packet was then saying, so in this first case, what does a equal? 1. It's a number in front of 2. There is no number in front of 2, so it's 1. How about this? What does h equal in this equation? What does h equal in this equation? It equals 0. There is no h. What does k equal? 0. Okay? It's just really identifying what these variables are. So now, we're going to graph the function -1 times 2 to the x. Okay? And we're going to see what happens when I make this negative. What does it do?
Mirrors.
It mirrors it. It flips it. Okay? It just flips it. And that should make sense. If I multiply this by -1, what do I get? -1/8. If I multiply this by -1, what do I get? -1/4. And so on, and so on, and so on. Again, the pattern could be the exact same. If I wasn't sure, I plug some numbers in. I see what my outputs are. I graph them. I get that. Fairly straightforward? Okay. Moving on. So what we want to do is we want to see which of the 3 variables controls the vertical shift, moving it up or down, of this function. We test drive it. We just see because we don't know, and that's okay. And this is where the calculator comes in handy, because we don't have to make table after table after table. So what do you guys think? Do you think A is going to cause this thing to shift up or down? Do you think H is going to cause this thing to shift up or down? Or do you think K is going to cause this thing to shift up or down?
Okay.
Okay, Martha, you said K?
Yeah.
All right, John, did you say K? Or no, who's that?
I do.
Michelle? Okay, Haley?
No, I don't understand.
Well, let's see.
We're adding the h and the k to the equation of the.
We're just trying to figure out, how do I move this function? Because right now, I've got this, right? I want to know, how do I make this function just shift up? Or how do I make this function just shift down?
Like
That's all I'm asking.
Why?
Like get steeper?
Not get steeper, just take the whole function, pick it up off the graph, and put it down
Oh,
somewhere
that's
else.
okay.
That's the y-intercept.
Okay, change the y-intercept.
That would be a, right?
No, that's K.
No, it's not.
Guys. Rel, yes, it is K. It's not A.
It's not.
No. Okay, so we're going to look at K. So Martha, what number do you want to try?
4.
4. So we're just going to add 4 to our equation. We're just testing it to see what happens. The reason why we want to do this is because later on we start wanting to model things with equations. But we need to know how to modify these equations so they actually match what's going on. Okay? Not every problem is going to go through 0, 1. John?
When you put that in there, isn't that x plus 4 is in the exponent?
No. If I wanted that to say x plus 4 is in the exponent, I would do that. The way this is read on the calculator is through order of operations. What comes first, exponents or addition?
Exponents.
Exponents first, then we add. Okay? The only way to supersede that is to put parentheses around it. Then it says parentheses first, then exponents, so on and so forth. So this is going to just take our function and move it up 4 units. Okay? So if I were to ask you guys, what is our, yeah?
I got the same thing, but x and the x and k were in the same place, like without putting parentheses.
You got the same thing, but x and k were the same place. What do you mean by that?
Like I got y equals 2x plus 3, and it's x plus 3 in the exponent.
Can I see what you're talking about? Sorry.
I got that same thing.
Okay. Let me show you how you should type it in then.
I mean,
So first of all, hold on. If I were to ask you guys, what is the horizontal asymptote for our second function?
4.
It's 4. Y equals 4. Okay? Martha?
Y.
Well, let's look down here. What is our horizontal asymptote here?
I don't know.
It's 0. It's a point we never cross. So if we weren't sure and we wanted to test that, here's how we do that. We make a table. Tables are your friend. Okay? And we've been using -3, but with exponential equations, maybe we want to get a little bit bigger, or rather, a lot smaller. So instead of just -3, maybe let's look at what happens at 0. What happens at -10? What happens at -100? And what happens at -1000? Okay? If you do this, I'm going to kind of screen through here. 2 to the -10 plus 4. What is that pretty close to? 4. Again, we're coming down and we're approaching 4. So in this case, we've got 4.00097. Let's put in 100. Okay.
4.
It says 4, but why does it say 4? What do you guys think?
See?
Reagan?
Because it didn't go through.
Say what now?
Because it didn't work correctly.
Has something not working correctly? Carlos? Okay, and that's exactly it. Your calculator can only go so far. Even the awesomeness of your calculator, it can only get so close to an approximation until at some point it says, not happening. I'm going to round to 4. Yeah.
So does that mean like there are just like a ton of decimal places?
Exactly right. What it means is that if I went too high too fast,
Yeah.
2 to the 100th power is a huge, huge number. And the calculator can't handle that big of a number. So it just said, 0 plus 4. Got 4. Okay? So if you did maybe -10, -20, -30, let's see what that looks like. -20, oops. That's pretty small. -30.
How did you do that?
Okay. If you want to know, talk to me later.
It's the same though.
It's not the same.
-20. Oh no, I'm just kidding.
It's really close. You couldn't measure this in real life, but it's not the same. Yeah.
But on the 100 one, couldn't it just do that thing? And it just do
I don't understand. We will pick this up again on Monday. Thank you. Have a good weekend.
I had a question.
Yes. Yep.
Mr. Morgan, should I end Nicole 2.0?
Yes, please.
You're soaking. You're not going back.
How do you end it?
The big red button.
Sorry.